Welcome. Today I'll tell you about a big leap forward. I got a big step further on the boxloader project. The drive chain mechanism are working, all plans and solution were spot on. To be honest, some details had to be changed during the building, but this sub-assembly of the project was done 99% according to plan. The purpose of the boxloader is to take a box from a table, take a picture of its content, and put the box onto a shelf. Whenever I need the box, the robot pick up the box and place it back on the table. This will hopefully give me a better overview of all my parts and projects. The project is split into 4 parts. The rails, the wagon, the vertical lift system, and finally the cart. The cart part is partially covered in some of the earlier videos in this series. Today I've gotten a long way with the rails. Testing the only part was quite fast. Getting hold of a lathe and getting it up and running was somewhat a much longer process. Learning the basics of machining a part according to specifications on a lathe was harder than anticipated, but eventually I got there. To lathe and machining people watching, bear with me, I am still learning. The ball bearings and the coupling have a 10mm hole and the sprocket has an 11mm hole. I have bought a 12mm axle. When I started machining the axle to 11mm, I was amazed how uneven the axle actually was. Look at the dark area on the axle. On to the action and mount the axle in the lathe. And machined the axle. The first one was really bad, so I found some more information. First of all, I had to validate that my tool was aligned to the center of the lathe. That involved a pointy pencil. Obviously, the tool is too high. The lathe had no way to lower the tool mount, that I know of, so back to an old tool I had lying around. The old tool aligned way better than the new one, so I waited for the new stuff, for no reason. And securing the axle in both ends will ensure more stability and hopefully a better finish. Drilling the center hole. After doing one pass manually, I remembered that the lathe can move the tool on its own. Engaging the self-driving mechanism, and I could sit back and watch the machine do the work. Unfortunately, the lathe have an issue. I cannot change the direction of the sledge movement. The lever is stuck for no apparent reason. Why I work in reverse. It is amazing to watch the machine just work its way along the axle and see things take shape. After the overall thickness was down to measurement for the sprocket, the ball bearing and coupling ends had to be machined. And the grooves for the lock rings to hold the sprocket and keyways in place. First finished axle cut to length, making the keyway hole in a not quite right way. And the keyway. Testing the ball bearing fit on the axle. Testing the sprocket fit on the axle. With some mild persuasion it was a fit. And done. The next step is to mount it all on the rails. Removing the old test rig and mounting the new one, the mounting holes were almost placed at the correct spot, adjusted to fit by turning things around. Mounting done in the passive end, onto the motor end. The motor assembly with ball bearings and all put on the axle. Building the box section to hold the ball bearings. Aligning the axle to the sleeper. I would hate if the chain fell off because of misaligned sprockets. Fastening the box section to the sleeper. I became aware that I bought two different types of chain. Not that it affected the functionality, but the difference in color irritates me. The hook had to be made smaller to fit inside the chain. Due to the size of the turnbuckle, I had to add a groove. This removes some of the rigidity of the box section, but I figure it's strong enough as the primary stress is in lengthwise direction. Tightening the chain. And testing the feel of the drivetrain. Mounting the motor. After mounting the motor, preparing for the test was a highlight. Did all my thoughts and load calculation fit, and would it work? Yes, it works. Testing was a success and everything drives without noise or unforeseen things happening. Notice the motor moving around when driving, on to mounting it. Fabricating the motor mounting plate, following my drawing. Unfortunately, I was out of M6 screws with the correct length. On to fabricating 4 screws with the correct length. And mounting the motor on the plate. I had made some miscalculations somewhere or messed up the measuring. The plate was too short. Instead of making a new plate, I added some spacers underneath to get the axle to the right height. With all mounting finished, it was time for the big test to see everything work and run as intended. To see the finished assembly in front of me was a big thing, after all the waiting, work and thinking I've put into it. With everything in place, it was time for testing with a load. When the chain was tensioned, the forces was strong enough to twist the sleeper towards the center, so a better rail sleeper mounting had to be found. I had some 45-degree plates and they should be able to hold the load. Aligning the plate and drilling the pilot holes. Unfortunately, the drill was not sharp enough. After some magic on the bench grinder, the drill made fast progress. Drilling in the rail without taking things apart cost me a drill. Implementing a new process, take things apart and then drill. I messed up a screw nut and could not unscrew the screw. The fastest way to handle the problem was to bring the angle grinder to take care of things. After assembling and remounting everything, it was time for the final test. Mounting the chain on the sprockets. The wagon. Fastening the chain. Tensioning the chain. Power. And time for testing. In one of my previous videos I got a question if I was going to use encoders, where I bravely stated I would use vision via webcam. After some talk with my hardware wizard, I went back on that decision. I aim to use encoders. Thanks for the question. That made me rethink my plan. For the controller software to be able to determine where the wagon is, I plan 2 stop switches and 2 motor kill switches, one at each end, to block damaging movement from the wagon. Encoder, motor controller, the first version of the switch was placed so the wagon could damage it and drive by, therefore the design was deemed not fail-safe. In version 2, the wagon can drive past but not damage the stop switch or the kill switch. The starting point for my hardware wizard for the new PCB motor controller board will be the I/O board 16. See the link in the description. The I/O board 16 version 1 has the following features. 16 inputs that can be pulled permanently to 5 volt via a jumper. The input and 0 volt are conveniently placed in the same connector. 16 outputs where the output and 0 volt are placed in the same connector. 4 PWM outputs. USB that can be a virtual COM port or a HID device. RS485 will be kept to make it possible to use the module in a future project. Version 2 of the I/O board 16 will get an interface to interface with an optical encoder and a PWM controlled motor controller for DC motors, at least 12 volts with 13 amps, but let's see what the hardware wizard can magic up. I aim to make the next phase of the project a vertical lift system, but no promises. The stability of the vertical poles is a major concern to me at the moment. I'm not quite sure how to stabilize this, but I will let you know in the next video. Right now I see the vertical cart moved by the same mechanism as the horizontal wagon, with some added counterweight to ease the load on the motor. To get the axle machined, assembling the rails and drivetrain was a major milestone in this project. Nice to give that part one big green check mark. Until next time, enjoy!